Amita Kashyap. I work as assistant professor at School of Computer and System Sciences. Today I am going to discuss about design and analysis of algorithm. Okay, first of all we discuss, generally we write algorithm to solve certain problems. Now real life examples, if we consider, there are several problems which can be solved through computation, like normal computation or by human beings. Few problems we have to use calculator to solve, and certain complex problems that cannot be solved by human, that we have to write a program. Okay, so we have to take help of computer to solve such kind of problems. For that we have to write program. Now program can be written using algorithm. What is algorithm? Algorithm is a sequence of steps or procedure with certain steps that is organized in certain way to solve certain problem, that problem with that we have in hand. So what is main objective of learning design analysis of algorithm? The main objective could be that we want to gain experience in fundamental technique to learn how we can analyze the algorithm, and we have to learn the main methodology that can be used to write efficient algorithm, so that we can solve our problem in efficient manner using resources in certain way. To study, and then also we want to study some most important computer algorithms for solving real life examples. Now what is computational problem? Okay, problem that is that has some complexity, that needs some computation to be done. That problem can be computational or logical. So what are the steps to solve any computational problem? The steps involve problem definition. We have to define the problem. We have to define what we want to solve. What is the problem actually, and how we want to solve it. So there will be definitely one statement that we consider as a problem, and we should be very clear what is the information available and what is the problem and what is the result we are expecting. So we have to clearly define the problem. The next step is development of a model. Among the available model, we have to select the right model to solve our problem. There are certain existing models available, so we have to choose among them which is best fitting to our problem statement. That model will be choosing to design our algorithm. The next step for solving the problem is specification of algorithm. Now we have to specify which algorithm and how we want to write it. So we have to choose among the available algorithms according to the problem we have or problem we want to solve. Next is designing of algorithm. Now there are different way of designing algorithm. Either we can start with the whole problem and then we start to break it into sub parts, and then gradually solving those small problems and gaining the result, and finally clubbing that result into one consolidated result. So our problem can be solved by dividing into certain parts. Likewise, we can have other aspects of solving the problem, so we have to design algorithm accordingly. Next step is checking the correctness of algorithm. Now correctness of algorithm can be checked several ways. We have to check whether our algorithm is giving the correct output. That is, each and every algorithm, a correct algorithm has to be. So how do we check the correctness of algorithm? We have to check whether what kind of input, depend on the type of the input we provide, either we are getting the expected output or not. That means the result itself proves that algorithm is correct. And other aspects are we should make sure that the algorithm is stopping at certain level. It is not like it is working on certain problem on certain data and it keep on working until for endless time. This should not happen. So algorithm should stop somewhere. So there should be some condition that limits the algorithm and stop it from execution. The next step is analyzing the algorithm. So we have to analyze the algorithm with respect to how much resources it takes, like how much memory it consumes and how much computation is required to solve this problem. And by analyzing our algorithm, we'll come to know whether our algorithm that we have chosen is correct or not. So that way also we can verify the algorithm we are choosing is correct. Then program testing. Once we write the program, once we are implementing the algorithm, we have to implement it using some programming languages available. So generally for this course we can take C or C++ language for implementing the algorithm in form of a program we'll be writing. Then program testing. Once we write the program using certain algorithm, then we have to test whether our program is giving the expected output or not, whether our program is satisfying the precondition, whether it is giving the proper output, whether it is stopping. So is it following all the criteria that is specified by the algorithm? If yes, then our program is correct program. And finally is documentation. That is a part of computational problem solution. So documentation why is required? Because once we write a program, then it should be clear to the user, whoever he is going to use this program, it should be clear to the user that how the program has to be used, what kind of input is expected, how the program will be processing the input, and what is the expected output. So the user of the program should be aware of how the program will be processing the data. So basically if we say what is an algorithm, it is a list of steps or sequence of some unambiguous instructions. Why unambiguous? Because our algorithm should be having clearly defined distinct steps. Distinct steps, that means there should be no repetition, because repetition will impose some overhead in the performance of the program. Overhead in terms of calculation, it could be in terms of memory usage, it could be. So algorithm should be distinct steps of a bunch of steps, okay, to solve the problem that we have in hand. So as you can see in this diagram, once we provide the once we have a problem in hand, then we apply some algorithm based on the available model. We decide which model to use and which kind of algorithm we have to apply for our problem that we want to solve, and we provide certain input to the computer. So along with input, we are running the program over the computer, and computer will be able to solve the problem according to the program written inside it, and will be able to receive the output. So what is the basic goal of having the algorithm? The basic goals could be the algorithm should always produce expected or correct result. Since we know the problem and we know what kind of data we are going to provide to solve this problem, so as a result we should be able to get the correct output. And the algorithm should terminate at certain condition. If we are supposed to process say 1000 records and process the data, make calculation, and the result we want to store into the disk or somewhere in the memory in form of a file, then we have to make sure that our program should stop somewhere. Okay, if we have like 100 records we want to process, then after processing 100 record, the program should be terminating and it should store the result at the proper form so that it can be further utilized. That is the main purpose of writing a program, to generate the reusability. So once it is running for one kind of data, it may run for other kind of data as well. So we can reuse the program. So that this program should terminate. That is one of the goal. So we have to write an algorithm in a way that it generates the correct output and it should be able to stop somewhere. And the performance issue. Sometime what can be done and what cannot be done with the available resources. These resources and computational power decides the performance of the algorithm. So whenever we are designing the algorithm, we should be aware whether what kind of resources we are having, how much memory we are having, and how fast processing is required. So all these parameters we consider when we design the algorithm. Characteristic of algorithm. What are the general characteristics that is considered as to decide whether algorithm is whether the steps of instruction are called algorithm or not? Because not all the sequence of steps can be called algorithm. Not all of them can be called algorithm. They should be following certain rules. So common characteristics found for algorithms are unambiguous. Each and every step in the algorithm should be unambiguous. Unambiguous means it should not be repeated and it should not be clumsy. It should have one meaning and that is clearly defined. Next criteria is input. There should be 0, or if there is more input, there should be clearly defined. So a program should be having clearly defined, algorithm should be having clearly defined inputs. Then output. Definitely we are writing an algorithm to write some program that can generate some proper result. So there will be certain expected result from the program. So 1, or if it's more than 1, then the output should be clearly defined. Next characteristic is finiteness. So our algorithm should be finite in nature. It should terminate after certain iteration. So depend on the conditions we apply in the program, the algorithm should be able to terminate after fulfilling that condition. Feasibility. Feasibility is another important characteristic of algorithm. We should check before writing any program, we should check whether the algorithm we are taking up is feasible or not. So feasibility can be measured or can be decided depend on available resources. Whether we are having proper CPU and whether we are having proper memory space to handle that kind of problem, that will decide what kind of algorithm we'll be able to take up. Next characteristic is independence. Okay, so each and every step should be clearly defined and there should be independent from the other program. So our algorithm is not program specific or any language specific, it is independent. It's like a pseudocode we write. So algorithm is independent from any programming language or programming code. Moving to classification of algorithm. Now algorithm can be classified in several ways. One is classifying the algorithm depending on the implementation method. How the algorithm is being implemented, that can also decide the different types of classification. So the various ways of implementing algorithm are recursion and iteration. Iteration means once we write, if you can recollect the for loop and while loop we used to write in C languages, that is iterative methods. So we want to perform some task repeatedly. So for performing such task, we write loops. So looping denominate the nature of iteration. We want to perform certain tasks on a repetition basis to achieve some result. So iteration based implementation of algorithm is also there, and recursion. What is recursion? Once we are performing some task and that function or that code block is calling itself again. If we are writing one function of addition, say 100 numbers from a file, we are reading numbers from a file and we are trying to add up that number, and then the function is written in a way that once it is adding, it is going back and calling the same function. So function is calling itself until all the data is exhausted. Then this kind of function call is called recursion. So algorithm can be implemented iterative way or in form of recursion. And few of the example of this kind of algorithm implementation are stack, queue, and tower of Hanoi. Okay, in stack we already know. In recursion we can do, in iteration we can do implement stack. How does it work? Whenever we have a block of memory specified as stack, we start with certain say top of stack pointer. We start adding some memory, okay, some data at that memory, and then at each and every addition, the stack pointer advances to one step ahead. So each and every time whenever we peek into the stack, we'll come to know what is at the top of the stack. That way. So the insertion in the stack can be implemented in recursive way or iterative way if you want to insert a bunch of data into the stack. Likewise, in queue we can handle this kind of algorithm. And Tower of Hanoi. Tower of Hanoi can also be solved using algorithm that is written in recursive way. Next is extract and approximation. Exact and approximation. So what is exact algorithm? The algorithm that can generate exact result to any problem, then that kind of algorithm can be said exact algorithm. Okay. And other type is approximate. So once the algorithm is not able to generate exact result for a problem, then that kind of algorithm is said approximate algorithm. So few of the algorithm of this type are sorting and NP hard problems. Next category we have is serial, parallel or distributed algorithm. So serial algorithm, once we are processing one algorithm step by step, we are writing one algorithm, steps are being processed step by step through one resource and generating output, then that kind of execution is called serial. And if we are dividing our problem into subparts and we are trying to execute all this part in the parallel concurrent manner, then at certain point of time all the parts will be solved, and finally at final stage we can accumulate them to get the final result. So this kind of problem solving is called parallel problem solving. And if this parallel problem solving is divided among multiple PCs, then that scenario is called distributed algorithms. The next category of algorithm is design, based on design methods. Algorithm can be developed through different design methods, and the design methods are greedy algorithm. Greedy algorithm, its name itself says it is greedy in nature. That means once we are solving the algorithm, we write the steps in a way that whatever locally optimum solution we have in hand, we choose that solution, and then we move ahead to next step. So how do we solve the problem? We solve problem step by step, and at each step we make decision based on what is best available option, without thinking about what will be the consequences in the future due to this locally optimal solution. So this kind of algorithm is said greedy in nature. Few of the problem that can be solved using greedy approach is fractional knapsack and activity selection. The next algorithm that is based on design method, that is divide and conquer. So what is divide and conquer? We have a complex problem. We divide into some sub problems until it is reaching to some concrete form, and then all these sub problems we solve it individually and we get the result, and all these sub results we club together and finally we get the final result. So that kind of nature of algorithm is called divide and conquer. So few problems that we can solve through divide and conquer are merge sort, quick sort, and so on and so forth. This kind of problem can be solved using divide and conquer technique. The other one we have is dynamic programming. What is dynamic programming? If we are making decision dynamically we are making decision for certain steps, then this kind of programming is say dynamic programming. So knapsack, 0-1 knapsack problem and subset sum problems are examples of dynamic programming. And there are few other classifications that are made for deciding the nature of the algorithm. They are randomized algorithm. So here the algorithm is designed in a way that the decision at each and every step are taken randomly. Okay, so randomized quick sort is one of the example of randomized algorithm. And complexity based classification. Depending on the complexity of algorithm, whether it is taking certain amount of time, so based on the time complexity and resource or computation complexity, the algorithm can be classified. Design and analysis of algorithm. So basic design says it's a how should be the design of an algorithm? Algorithm design should be in a way that the cost of algorithm is minimized, or it could be kept minimal. So cost of algorithm can comprise of the memory it required to solve the problem, or the number of steps, computational complexity, that is number of steps it will require to solve the problem. So definitely if we want to write some algorithm and we want to write a good algorithm, then it should be incurring less in the cost. So cost should be less. Now question arises in your mind, what to analyze? When you are analyzing algorithm, when you are speaking like we want to analyze algorithm, what shall we analyze? So we want to analyze and we want to predict the cost of algorithm in terms of resource it is going to take and the time it is going to perform the operation and generate the result. So resources consumed, that we can count in form of the memory or the bytes it is taking, and performance time taken, that is once we start the application, start the process, we provide the input, how much time it takes to generate the output. On that two parameter we can analyze whether the algorithm in hand is good or not. And then why to analyze? Why do we want to analyze an algorithm? Because we want to find out whether the algorithm we have chosen, through the model we have chosen, whether it is right for the problem we have in hand, or whether there should be some changes, or there should be some other option or other algorithm we should be taking to solve the problem. For that we have to analyze the algorithm in on the basis of certain parameters that I discussed just now. So what will we be analyzing? We'll be analyzing the consumption of resources and the time taken. And why do we analyze? Because we want to find the efficient algorithm that will yield into good result. That means it will incur less cost, and that kind of program that is written using efficient algorithm, that program is best selling. That means that it will be more accepted by the user. They'll be using it more frequently to solve their problem. Next is, why do we want to analyze? For getting the better use of hardware and other resources. Once we are writing program to solve some problem in hand, then the hardware utilization should be good, and we want to or the programmer can demonstrate the good skills of programming through good algorithm. Once programmer is asked to write some algorithm, and he's going to be evaluated based on the performance in the algorithm, then definitely the algorithm should be precise and compact. It should be taking less amount of memory, and it should be accomplished within less number of statements, that we call line of code. We measure our program in terms of line of code as well. Algorithm design technique. As we discussed earlier, the algorithm can be classified depending on the technique it is using for its design. So if we have a complex problem in hand, there is certain approach that bottom up or top down. Okay? So if we have a complex problem in hand and we want to solve it, so there are certain ways. One is like we divide it into small modules, and then further divide it into sub modules, and then we solve it. So this breaking up problem into small module, that technique is called modularization. Through modularization, we develop multiple modules and then divide that module into sub-modules, and finally when it reaches to certain low level of complexity, then we go and solve it. So this kind of problem is called divide and conquer, or we can say it is top-down problem. So top-down approach of solving the problem. Another way we have is we focus on small steps. We club those steps and finally design some logic that can finally solve our complex problem. So we start with the small steps and then club them and make a module, and then the module result can be clubbed as a whole result or whole output of a complex problem. Then this approach is said as bottom-up approach. What are the goals of having different design? That is, we want to break the problem into modules, turn the complex algorithm into a simpler algorithm and comprise of independent steps and modules, and it will be simple to implement, simple to debug, and simple to test for the programmers. Algorithm efficiency analysis. Algorithm can be analyzed using two different stages. Okay, so they are analyzed at different stages. One is when algorithm is implemented, that is before implementation, and after implementation. If we are analyzing the algorithm before implementation, then it is called a priori. Okay, a priori analysis. And once we are implementing the algorithm and then after we are observing the performance of the algorithm, that kind of analysis is called a posteriori analysis. So a priori analysis, it is kind of theoretical analysis where we consider a certain function and we assume that rest of the factors that generally affect the algorithm, they are constant. That means they are not making much modification or much impact on the algorithm. So theoretical analysis is called priori analysis, and it is the efficiency is measured by assuming that other factors are constant and they are not going to affect the algorithm. Other kind is once we implement the algorithm and then we start analyzing the algorithm. That method is called a posteriori analysis. So a posteriori analysis, that is empirical analysis. So what we do here, we implement the algorithm using some programming language. So definitely once we are writing a code, it will have a size in terms of number of instruction we are writing in the program, and then we run that execute that program. So we actually come to know how much computation time it is taking and how much space it is occupying to solve the problem or execute the program. So this kind of analysis of observing all this factor is called a posteriori analysis. Through posteriori analysis, we can actually determine the performance of algorithm in terms of computation power required and the time and space complexity. Okay, how much space it is going to take. So let's talk about complexity now. Now we have design concepts clear with us, how we can design the algorithm, then what should be called an algorithm, how we can analyze the algorithm either before implementing it or after implementing the algorithm in form of some program. Then we analyze the parameters, that the actual parameter, either it is computational or storage it is taking. Next comes the algorithm complexity. Now we have to determine how complex the algorithm is. Whether it is too much complex, then we should go and find out some easier algorithm. Okay, it should be optimal. That means it should not be very complex. The problem is complex, but the solution should be in a simpler manner so that it doesn't involve much computation while the algorithm is being executed or implemented. So it should not be complex. That means it should not be taking lot of processors time or lot of processing, or it should not be taking lot of memory to solve the problem. So algorithm complexity, it depends on two factors. These two factors are the time and the space. The time, that means algorithm should be taking minimum possible time, and the space, that means algorithm should be taking less space to solve the problem. Okay, now talking about space complexity, let's have a look at one small algorithm. Few steps I have written. This is a common algorithm of summing two variables. Okay, so what we just start with step 1, and what do? We take up first variable, then we take up the second variable, and then we make addition or some numerical value also we can add up, and then finally we stop. So our main purpose is to adding two values. Okay, so these are the steps involved into solving the problem. So how do we decide how much space it is going to take, or what is the space complexity of an algorithm? That will depend on how much space these steps are going to take. So there are two parts of space complexity. Okay, two components play a role. One is fixed part, one is variable part. Fixed part is something that is required by constants or variables that we are going to use in the program, or the size of the data that we are going to deal with. Okay, it may vary. Here it is just one variable, okay, that we are going to add up. But we may have program that we have to process the entire file of 100 or 1000 of record. Then the input file size also matters while calculating the fixed part of the space complexity. The other component we have for space complexity is variable part. This variable part, that will depend on the problem size. what is the size of a problem, like recursion is going to be taken up or going to be involved in the program, or some stack is functioning in the program to solve the problem, then that variable part, that is a variable part. So it will be determined only when program is implemented and executes. These two components comprise and made up the space complexity. So if we derive some formula for space complexity, then it could be denoted as S into bracket P is equal to fixed part, that is denoted by C, plus variable part, that is denoted by some I. Okay, the complexity is summation of fixed part complexity and variable part complexity. Here for this example, the space complexity of these 3 steps return will be 1. 1 is fixed because we are going to have a data as a number 10, that will be taking 1 unit, and 3, that is computational. So we are going to take 3 variables A, B and C. These all will be taking 1 unit each. So 1 plus 3, that is complexity is number 4. The next complexity type is time complexity. So how do we determine what is the time complexity of an algorithm? So we calculate the amount of time the algorithm is going to take. So that amount of time can be that will be amount of time taken by one statement. If we are going to have 10 statements in our program, then the amount of time it is going to take will be multiplied by 10. So if we derive this equation for time complexity, it will be T into bracket N is equal to C into N. So N is number of statement we have and C is the constant time that is required to execute that statement. So next we will be discussing, in next lecture we will be discussing the asymptotic analysis of notations and asymptotic notations. So that's all for today, and in next class we'll be discussing asymptotic notations and how they are written and how they are useful to decide the algorithm characteristic. Thank you.